Assalamu alaikum, my name is Shahriyar, and in today's lecture we will study what is the FIR filter or fast impulse response filter. So there are two basic things which we will discuss here. The first one is fast step response, and the second one is fast roll off. So now we will see what is the basic equation for FIR filter, which is y of n equal to summation I equal to 0 to k bi x n minus I. Here pi is basically the filter coefficient, while this one is the basic filter design equation. So now we will expand this equation, as here it is from 0 to k, so now we will expand it like first put I equal to 0 in this place, so it will become b0 x n plus, then I equal to 1 b1 x n minus 1 plus so on, and then put I equal to k, which is bk x n minus k. So now take the z transform of this equation, which will be like b of 0 x z plus b of 1 x z into z inverse and so on, then b of k x z into z power minus k. So now we will take its transfer function, which is h of z and y of z divided by x of z. Just take x of z common from this above equation, and then we will get b0 plus b1 z inverse plus so on bk z power minus k. So now let's take another example, which is, suppose we have an example y of n equal to 0.1 x of n plus 0.25 x of n minus 1 plus 0.2 x of n minus 2. So here we know what is the first step. The first step is just take the z transform, which is 0.1 x of z plus 0.25 x of z into z inverse plus 0.2 x of z into z power minus 2. This is the z transform. Now just take its transfer function, h of z, which is y of z divided by x of z, and we'll get 0.1 plus 0.25 z inverse plus 0.2 z minus 2. So here we get the following question: b0 equal to 0.1, this one, and here this is the b1, which is 0.25, and this one is the question b2, which is 0.2. So these are our required coefficients for this example. So which is the fast Fourier transfer design. So here we have some formulas for Fourier transfer design. The first one is h of e power j pi equal to summation minus infinity to infinity cn e minus j omega naught n pi, where the formula for c of n equal to 1 by 2 pi integral minus pi to pi h of e j pi into e j omega naught n omega, where the value for n is from minus infinity to plus infinity. So let's design some other formulas for Fourier transfer design. The first one is at n equal to 0, the h of n will be 1 by 2 pi integral minus pi 2 pi h of ej sigma and e power j sigma n, and at the end n pi. So when we put n equal to 0, then we'll get 1 by 2 pi integral minus sigma to sigma 1 d sigma, and here we get h of 0 equal to omega c divided by pi. So this is the value for n equal to 0. Now we will find for n not equal to 0. So for n not equal to 0, h of n will be 1 by 2 pi minus pi 2 pi h e j omega into e j omega n, and here d omega. So its value will be, after solving this equation, we will get this equation and then put the limits from minus pi to pi. We will get the value of h of n equal to sine omega c n divided by pi n. So we get two values here. The first one is h of 0, which is omega c by pi, and the second one is omega of h of n, which is sine omega c n divided by pi n. So these two formulas, we will use this formula later on. So thank you for watching.